Hello. In this video, I will try to describe the relationships between function and its derivative and functions and its second derivative. The relationship between function and its derivative, first derivative, is more popular knowledge from the relationship between function and its second derivative. At least the reason is popular. But the reason of the relationship between second derivative and the function is less popular. Let's observe what's going on this dynamic application. As you know, the derivative means the tangent at a specific point of a function. And the first derivative like that. When the first derivative is positive, it means the tangent of this line is positive, the function is increasing. And when the first derivative is negative, the function is decreasing. It is easy to observe and easy to understand. The critical point from the derivative is negative to the passing point from the derivative is negative to the positive is an extreme point, and at that point the derivative is 0. You can observe numerically also. This is easy and popular knowledge. What about the second derivative and the function? We can also observe the derivative function like this. You can see that the derivative function of the function, the first derivative of the function is positive, and from minus infinity to the a, the function is increasing, and the first derivative of the function is negative value, takes the negative value between a and b, and the function is decreasing. Let's hide the first derivative and think about the second derivative. The second derivative is related to concavity of the line, concavity of the curve. What does it mean? The typical concavity is not same for every interval. If it is increasing, for example, minus infinity to a, function is increasing. It is also increasing from b to infinity, but from b to infinity the function is the curve of the function is concave up, but minus infinity to a, the curve of the function is concave down. And we can also observe that in this interval function is decreasing. Actually, the whole interval, in this whole interval, the function is decreasing, but somewhere here the concavity is changing. In this interval, the concavity is concave down, and in this interval, concavity is concave up. What does it mean? Let's observe the relationship between derivative. Here, from minus infinity to a, function is concave down, and the derivative is, tangent is decreasing. I am repeating, the function is concave down, the curve of the function is concave down, and the derivative, please observe the value, the derivative is decreasing. Derivative is decreasing. And from a to plus infinity, the function is concave up and the derivative is increasing. So the concavity is related to the function's derivative increasing or decreasing. Similar to relationship between function and its first derivative, the similar relationship exists between first derivative and second derivative. Let's comment this relationship in terms of second derivative. When the first derivative decreasing, the second derivative will be negative value, will take negative value. When the first derivative is increasing, the second derivative, the derivative of the derivative, will take positive value. Let's see the second derivative. Like this. This line is second derivative's line, and somewhere here, from minus infinity to a, the second derivative takes negative value, and from a to plus value, plus infinity, the second derivative takes positive value, and the function is concave up and the function is concave down before a.